어떤 컬러로
Santino has recently been failing his math class. He hasn't been paying attention at all, and his grades are dropping. Now, out of desperation, he tries to seek an answer for his problems.
Mister, would you like to play a game?
Are you a scammer? I don't have money.
No, it's a different kind of game. Have you ever heard of Ducky? Choose a paper.
Blue one.
Alright, blue it is then.
Alright, let's imagine a scenario. McLawrence and Rowie are playing Ducky. You've heard of it, right?
Yeah, it's a kid's game. What about it?
They each take turns throwing their tiles at each other. Each of them has a certain chance of flipping the opponent's tile. The probability of McLawrence flipping Rowie's tile on a single throw is 3/4. The probability of Rowie flipping McLawrence tile on a single throw is 4/5. Here's your question. What is the probability that both McLawrence flips Rowie's tile and Rowie flips McLawrence tile in a single round when each player throws once?
I don't know, 7/9?
Incorrect.
Ow! What was that for?
Hint. Remember the rule of multiplying probabilities for independent events.
Independent multiply. Okay, so it's 3/4 times 4/5?
Getting warmer. Try again.
Okay, so that's 12/20, which simplifies to 3/5.
That's correct.
Welcome to the first game. I will now explain the rules. Your task is to carve the shape out of the candy without breaking it. You will have 10 minutes. If you succeed, you will advance to the next round. If you fail, you will be eliminated.
I've played this game before! I said I've played this game!
There are 4 shapes: circle, triangle, star, umbrella. The circle has 70% success rate, triangles 50%, stars 30%, and the umbrella only 10%.
Okay, in the Dalgona game, I must successfully carve a shape from a sugar cookie without breaking it. I must randomly pick one of the 4 shapes, which are circle, triangle, star, or umbrella. Each shape has a different success rate for carving, which circle has a 70% success rate, triangle having 50, and the star having 30, and the umbrella just having 10. After I carved out the first shape successfully in round number 1, I advanced to round number 2. However, for round number 2, I randomly get another shape, which may be the same or different from the other. After I carved out the first shape successfully in round 1, I advanced to round 2. However, for round 2, I just randomly get another shape, which may be the same or different from the one I selected in round 1. What is the probability that I successfully carve out both shapes, both rounds, and win the game? Since we have 4 shapes in the first round, and the same 4 shapes in the second round, we multiply them and get 16 for the total number of possible pairs of shapes. After we get this number, we'll then manually compute the combined success rates of those possible pairs of shapes. We'll get this by multiplying the individual success rates. Since each pair of shapes is equally likely, we sum all the combined success probabilities and multiply by the possibility of selecting any pair. Therefore, the probability of me winning the Dalgona game is 16%.
Choose a partner. You will be playing a game of marbles against each other.
Sparrow, yes!
Marbles? What are the odds here? What's the game? How do we play?
We each have 10 marbles. We take turn turns, hiding some in our hand, and the other player guesses if it's an odd or even number.
So, it's a guessing game. But there's a strategy, right?
Guess right, you win the marbles they're holding. Guess wrong, you lose that many to them. You have to try to outsmart your opponent.
But what are the actual probabilities? Okay, let's say I hide, say between 1 to 15 marbles in my hand. My partner guesses odd or even. It's a 1/2 chance of being right, no matter how many I hold, right? So, in the first round, the probability of guessing right is 1/2. What about the second round? Same thing, 1/2. I need to add the possibilities and subtract the chance of both happening. Right? It's like in Dalgona. It's like the shapes in Dalgona. I need to add the probabilities, then subtract the chance of both happening. 3 over 4, 75% chance of guessing right.
And so, with that, Santino was able to win the Newton Games. But at what cost? Was it worth it? Or was it all a dream?